All right. Thank you. I want to thank the organizers of this conference for having me here. It's quite an honor. My name is Fred Pelletier. I'm the chief scientist and co-founder of North Star Earth and Space. We're a Montreal-based company. We also actually have offices in Europe, in Luxembourg, not quite Germany, but a little bit close. And I'm here to talk about a very cool problem, challenging, a little bit scary. It's the problem of space debris and space security of assets. So before I begin on that topic, I just want everybody to realize that we cannot really live without space nowadays. It may be something that you've heard many, many times, but it's a true fact. And the basic example is the maps you all use on your smartphone. That comes from GPS, but there are also other areas of really important use of space, space weather, or just weather on Earth. Also, the security of our planet is dependent on space, and like it or not, the conflict that we have on Earth, for example, in Ukraine or in Israel, are supported by satellite communications. And very recently, we've seen indications that the Russians were spying on those satellites that supported the Ukraine troops. So it is a serious problem at that level, and also from a traffic problem. So moving on, when I was younger, or maybe a little bit before, the space race was all about the big nations to demonstrate capability to conquer this new frontier. But today's space race is about commercial. You've all heard of Starlink, but there's several others that are deploying a massive amount of spacecraft in space. And even maybe not as known, but the Chinese are proposing a constellation of 13,000 satellites to be launched. Starlink, we're talking about 42,000. It's a crazy amount of numbers. Those are the kind of reality that we're already facing with. So traffic in space is complicated from that point of view. But not only that, the growth in space object is happening at an exponential level. Right now, I think that there's about 9,000 objects that are active satellites in space. That's already an impressive amount of assets to track and make sure that they don't collide with each other. There's maybe 45,000 objects being currently tracked by the United States and European systems. But the estimate of the actual density of objects in space is about 10,000 metric tons of stuff up there. And if you want more numbers, I have them on the slide. Objects that are maybe a marble size, 1 centimeter and up, are in the 1 million range. Those are lethal to spacecraft and human lives. I just listened to this chief scientist of the NASA Johnson Space Center earlier this week in a speech, and he was saying that the protection for astronauts when they do an EVA is at a few millimeters level. So those objects, the million that I'm talking about, are really lethal. And the 1 millimeter and up, they can damage and cause problem to satellite and have a cascading effect of more debris. And we're talking about the 100 million objects over there. So it's a challenging problem, and you already know why AI is quite important to solve this, because tracking all that amount of stuff is just almost impossible for human beings to, with a team. A lot of people are looking at this, but you need the machine to help us. And we humans have invented a great algorithms with AI, so we are using it. This video is it was made by my colleagues at NASA Johnson, where they took a relatively modest or normal sized satellite and put it in a lab. They threw a bullet at it of a typical example of what a space debris might be, and it created 85,000 debris collected around like a foam pad around the thing. So that gives you an idea of the problem that we're facing. So what is North Star going to do about it? So our objective is to launch a series of satellite in blocks and to form a constellation of telescopes to look at this and track them at all time from any location in the world. Traditionally, this is being done right now by radars on the ground and telescopes, and they're great systems, but they have limitations. The main limitation really is the fact that our Earth is covered by 75% of ocean, and you can't really put a radar on a ship in the ocean, even though I'm being told that it's being done a little bit experimentally. But really, the way to solve this was to launch satellites in low Earth orbit and polar orbit and scan the sky. That's what we're doing. And I do have another animation to give you an idea of what we're doing. So we're going to launch the first batch of satellites on January 10th of 2024, next year. Quite happy about this. It's been a long journey, and essentially multiple planes will follow up in order to scan the whole sky. So now moving on to artificial intelligence and machine learning. I said it already, but it's a big data challenge. And listening to the talk this morning on the aero side, or even Leonard did just talk, it's all about data, a massive amount of data, and we need the machine to help us. So for us, we're talking about 2 million images per day. So we're collecting literally images of white dots in the sky, just like astronomers do. And we're going to try to detect these objects using algorithms and data pipeline processing. Finding 100 million objects and correlating them is a massive amount of work, and that's why we already began to use AI to do this. The success of this involves all the things I'm listing here. Data curation is simply about organizing the data, and definitely AI plays a role here, but think of it as a library of books. If you were to walk in a library and try to find your favorite book and it's all a pile of stuff on the ground, you have no idea. It would take forever to find it, but if it's organized, then you can quickly find what you're looking for. So that's what data curation means. And then fusion is the data exists from a system. We want to leverage and cooperate with others to bring all of this together, and there are different levels of data that we need to fuse. So collaboration is key to the solution, and when I talk about collaboration, it's about between government, industry, academia. It's also about different fields. I love this conference or this workshop because we're talking with different people. They're aeronautics, but here in Montreal, we're already leveraging the knowledge that we have from the video game industry, the medical industry. So that's what I'm talking about. And I guess the third aspect of collaboration I want to talk about is international. How do we work together between agencies, between companies around the world? In fact, I'm going to go to, I'm scheduled to leave to Munich tomorrow on a flight. Quite an interesting aspect given I'm talking to Berlin right now. So it is a collaborative workshop that we're doing with the allies on the defense side of things. And there's going to be obviously representation from a lot of German industry, including DLR will be there. And from the talk I just had, I just listened to from my colleagues. I'll wrap it up really quick. It's obvious that Airbus and DLR are really small companies, so I shall all see you in Munich, right? Anyway, okay, I want to spend 1 minute on this, if I may, just to give you an idea of what we are doing for AI right now. So we are leveraging the algorithm to classify objects that we're looking at. It's a multi-dimensional problem. When you look at an image with an object, you're not only seeing a position in the sky, you're seeing a visual intensity, how much photons you collected, you have directional information. It becomes really complex to analyze, and AI helps us to do the job for us, so we can move on. So I'm going to stop here with this just quick video showing what the type of work that we're dealing with. This was a simulated event done by Air Force Research Lab for us. This is a collision in space of an object, and then some early view of our algorithm detecting the objects here. Thank you very much.